prove that n to the power of 5 minus n is divisible by 5 for all n in the integers. Well, this bit is given here as the factorised form as n to the power of 5 minus n, just to make this a little bit easier to analyse. So we're going to prove this using what is called proof by exhaustion. And proof by exhaustion is where we identify all the possible cases. So here, in this first step, we have identified all the cases. And in this case, the cases themselves are the fact that the values of n can only take one of 5 forms. They can either be a multiple of 5, or they can be 1 more than a multiple of 5, 2 more than a multiple of 5, 3 more than a multiple of 5, or 4 more than a multiple of 5. If we kept going and got 5 more than a multiple of 5, we would go back to being a multiple of 5. So every single integer can be written in one of these 5 forms. So that's the first step of our proof by exhaustion, to identify all the possible cases that we're going to consider. Once we've done that, we have to show that it works for each of these possible cases. To make it a little bit more short, I'm going to let n to the power of 5 minus n be equal to big N. That way I can refer to big N throughout the proof rather than having to repeat writing this every time. So then we analyse each case. The first case, case 1, is when n is equal to 5k. So that is substituting into here a multiple of 5. If we do that, if we substitute a multiple of 5 into this, then the factor n here, is going to be divisible by 5 because it's a multiple of 5. If that is a multiple of 5, then the whole thing is a multiple of 5. And so we have shown that when n is equal to 5k, that thing must be divisible by 5. In the next one, in case 2, where it's 5k plus 1, we're going to show that n minus 1 is a multiple of 5. Because n minus 1 when n is 5k plus 1 is 5k plus 1 minus 1, which is equal to 5k. So in this case, this term here is divisible by 5. If that term there is divisible by 5, the whole thing is divisible by 5. In case 3, we're looking at n equals 5k plus 2. When n is equal to 5k plus 2, now we're going to look at this factor, the n squared plus 1. Well, let's substitute 5k plus 2 into here, and when we expand it, we get something that's divisible by 5. So now we've shown that when n is equal to 5k plus 2, the n squared plus 1 term, let's scroll back up, that's this term here, is divisible by 5. And if that term is divisible by 5, then the whole thing is divisible by 5. In case 4, we have a very similar approach to it here. This is the 5k plus 3 term, but in this case n squared plus 1 also expands to a multiple of 5. So in exactly the same way as case 3, the whole thing must be divisible by 5. And then the final case, case 5, is when n is equal to 5k plus 4. And in this case, if n is equal to 5k plus 4, then n plus 1 is equal to 5k plus 5, which is a multiple of 5. So in this case, the whole thing must be a multiple of 5 because n plus 1 is a multiple of 5. And if we go all the way back up here, in this case it's this one here that's going to be a multiple of 5. So what we have done there is show that for each of these 5 cases, we're guaranteed to get that big N is divisible by 5. So concluding this whole process, this proof, we say in all cases n is divisible by 5. Therefore, n to the power of 5 minus n is divisible by 5 for all n in the integers. This symbol here sometimes trips people up. This is a shorthand for saying for all. So a proof by exhaustion, as we can see here, is split into several parts. First, we have to identify all the possible cases that we're going to consider and justify that they are all the possible cases. Then we have to, one at a time, prove that those cases satisfy the condition we're trying to prove. Once we've done all of that, we finish our proof with a conclusion saying that we have shown it is true for all the possible cases, therefore it must be true in all instances.